Hello, this is the third video of the third complex number series for OCR Pure Core AS for Mathematics, and it considers multiplication of complex numbers that are given in modulus argument form, otherwise known as polar form. Addition and subtraction of complex numbers in Cartesian form is easy, but multiplication, as you can see in this slide, involved expansion of brackets and use of I squared equals -1. We will shortly see that multiplication of complex numbers in polar form is easier. Here we can see the multiplication of two complex numbers Z and W shown on using GeoGebra as a dynamic way of showing you this. As you can see, we can move and exchange the points that we have for Z and W. You can see that the multiplication of one complex number by another involves a combination of an enlargement and a rotation. So, considering complex numbers given in the modulus argument form, here Z1 equals R1, brackets cos theta 1 plus I sin theta 1, and Z2 equals R2 cos theta 2 plus I sin theta 2. When we expand this out, we can see that using the compound angle formula, we get a result which is R1 R2 cos theta 1 plus theta 2 plus I sin theta 1 plus theta 2. You may wish to pause the video at this stage and follow this all carefully for yourself. This result leads us to the conclusion that the modulus of Z1 Z2 equals the modulus of Z1 multiplied by the modulus of Z2, and that the argument of Z1 Z2, that product, equals the argument of Z1 plus the argument of Z2. This result allows us to quickly multiply complex numbers when they're given in modulus argument form. Looking at this example then, if we were asked to find Z1 Z2 in modulus argument form, we would know that the modulus of Z1 Z2 equals, in this case, 6 times 4, which will equal 24, and that the argument of Z1 Z2 will in this case equal 5 pi by 6 plus minus pi by 4, which in this case is 7 pi by 12. Therefore, Z1, Z2 can be written in polar coordinate form as 24, 7 pi by 12, or in the modulus argument form of 24 cos 7 pi by 12 plus I sin 7 pi by 12. We do of course need to check that the principal argument, the 7 pi by 12, lies between minus pi and pi. In this case, that's alright. You may want to pause the video here and check the working carefully for yourself. Here is a second example. In this case, we know that the modulus of Z1 Z2 will equal 2 times 3, or in other words 6, and that the argument of Z1 Z2 will equal 5 pi by 8 plus 7 pi by 8, or in other words 12 pi by 8 or 3 pi by 2 if we cancel down by 4. Here we need to be quite careful and note that the 3 pi by 2 is greater than pi, so if we were to do a sketch, we would find that we were going to have a purely imaginary answer. In this case, we'll find that it's minus 6i, and that also the principal argument needs to be written as minus pi by 2, in order that theta lies between minus pi and pi. Once again, you may choose to pause the video and work this through carefully for yourselves. In the next session, we will look at how to divide complex numbers that are given in modulus argument or polar form.